Hi, sixth hour. I had to go to a meeting for some curriculum kind of stuff, so it kind of threw off all the plans. Sub will tell you what's going on, but still wanted to move ahead with section 5.3 a little bit and just make some progress today. So 5.3 is all about factoring and solving some quadratics, solving some different quadratics. Okay, the biggest part of this is factoring. Okay, so just some general things with factoring. Always, first thing you should do is look for that greatest common factor, whether it's there's a factor of 3 in every single term. You factor that out, you bring it out in front. Maybe there's a common factor of an x or an x squared, something like that. Any common factor in every single term, move that out in front first. Then, if you've done that, or if there isn't anything like that, the second step is look for a specific pattern. All right, we'll talk about some patterns of some common things that can just factor in a certain way. And we'll talk about that in some of these examples. And if there isn't one of those, you just start working on whatever you can. So we're just going to do a bunch of examples. There's not a lot of just notes to take. It's just working through some examples. All right, so to factor this, we're looking for common factors in every single term. All right, factors are things multiplied together. So this is 27 times c squared, which is really c times c. This is 18 times c. Okay, you're looking for common factors in each term. This is a term, that's a term. So 27 and 18, just looking at the numbers, the greatest common factor is 9. So we're going to bring that out in front. And there is a common factor of c in each term. So we're going to factor that out. And what that means is just moving it out in front. We're going to put some parentheses. And what's left is 9c times what gives us our original amount. So 9 times 3 was a 27. C times c is the c squared. Then we just have a minus. 9 times what gives us 18? That's the 2. C times what gives us c? Well, that's just a 1. We don't need to put times 1. And that's factoring. All right? You can always check your work by doing some distributive property. 9c times 3c is 27c squared. Minus 9c times 2, 18c. So this works. This is our answer. All right? For the second example, again, you're looking at common factors in each term. So it's 5 times z times this parenthesis. Those are 3 factors in that first term. There's that subtraction sign separating the terms. In the second term, we got 2 times. This whole parenthesis is 1 factor. All right, so looking at these 2 terms, the common factor, the only common factor is that quantity of 2z plus 1. So when we factor that out, in the first term, we factored this out, it's accounted for, so what's left? It's just a 5z. Minus, to go to the second term, we factored out this 2z plus 1, what's left? 2. And that's the factored form. All right? Now, we're going to talk about some terms where we have some quadratics where we have the x squared term and an x to the first power term. To factor these things, you're really going to be doing FOIL in reverse. So this top example, we're just going to do the FOIL. All right, x times x, the first terms, is x squared. The outside terms is x times 3, so that's a plus 3x. And then the inside terms, 2 times x, so plus 2x. And the last terms, plus 6. Okay, now it's this outside and inside terms that add to give us that middle term. So we got x squared plus 5x plus 6, okay? This is an important idea. Outside and inside add to give you that middle term. So now, when we factor, we're doing FOIL in reverse, okay? We are looking, when we have an x squared term and an x term with that constant, we're looking for those 2 binomials. X plus 2 is a binomial. There's 2 terms. X plus 3 is a binomial. There's 2 terms to it. So when we have this kind of equation or expression, it can factor to two binomials. But you're doing FOIL in reverse. So this first term that we had here, it came from the first term times the first term. So to get x squared, that's x times x. Now, the last term, this 6, it came from last term times last term. So we're looking for two numbers that multiply to be 27. So I'm just going to make a list. 1 times 27, 3 times 9, and that's it. Okay? So the middle term, our 12x, if we look back at that first example, the middle term, it came from the outside and inside, which was those numbers. So which of these combinations, the 1 and 27 or the 3 and the 9, would add to give us the 12x? It's 3 and 9. So we go plus 3 plus 9. Okay, and again, we could do the FOIL to check our answer, to bring it back to the full version, and it's correct. So this is how that trinomial factored. Okay, same idea here for this next example. It's going to factor, hopefully. So it's going to be x times x. That's the easy part. Numbers multiplied to give us a negative 54, add to be negative 15. So factors of 54. A lot of times I'll just make this list of these numbers. 1 times 54, 2 times 27, 3 times 18, see, 4 does not, 5 does not, 6 times 9, and I do believe that's all of them. So, which of these could combine to 15? Well, there's actually a couple. Now, again, we're trying to get to negative 54. So, we have some things to check out. It could be a negative 1 times 54, negative 2 times 27, and so on. It could be this, 1 times a negative 54, 2 times a negative 27. Again, we're multiplying to give us a negative 54. 3 times negative 18, 6 times a negative 9. So, which of these sets of factors would add to be a negative 15? You got to be looking right here. 3 plus a negative 18 is negative 15. So this is a positive 3 and a negative 18. And there's our answer. Okay, this is the factoring. Now, it gets a little bit tougher when the term in front of, or the coefficient of x squared is not 1, but you're still doing the same kind of stuff. All right, so to get 2x squared, it's coming from the first terms. So it's got to be a 2x times 1x. To get the 15, it's got to be 1 times 15, and it is negative. So it could be one of those two ways. To get 15, we could also do a negative 3 times 5 or 3 times negative 5. So what makes these more difficult when that coefficient in front of the x squared is not 1 is you just got to try and figure out the right combination of factors. So our inside and outside terms, they got to combine to be a negative 1. So the first two factors here and here probably aren't going to work. To get 1, we're just too far apart with the 1 and the 15. So I'm going to look at the negative 3 and 5, and I'm just going to try. So minus 3 plus 5. Now, to check, we're just going to do FOIL. So we know the 2x squared is right. We do the outside terms, that's a plus 10x minus 3x. Okay, so that is not going to combine to be a negative 1x. So that's not the right combination. You can also try the other way around. We could put a plus 5 here and minus 3 there. Still the same set of factors, but changing the spots. So the 2x squared again is correct. Outside terms, minus 6x plus 5x minus the 15th for the last term. Those two middle terms, there's negative 1x. This is what we want. Okay, so it's a little bit more work, but it's mostly just checking. Okay, it's guess and check, yes, but it's limited guess and check. You've only got a few options to try. So let's go to this first example. Okay, to get 5x squared, you've only got one possibility, 5x times x. Now we're trying to get to 8. So it's a positive 8, so 1 times 8. And notice how everything is positive. Okay, there is some clues with the signs there. Because everything's positive, you're not going to deal with any negatives. So we don't have to worry about that. And 2 times 4. Those are our only options. All right. Now, we are trying to get to a middle term of 14. So, with this 5x, when we do our outside and inside, it's probably going to be our second set of factors, the 2 and 4. If I were to put the 4 here, the outside terms would give me a 20x. With a 2 here, that's a 2x. That's not going to work. So, it is guessing and checking, but you can start to mess with the numbers and see where the numbers should go just by a quick glance. If I put a 2 here, that's going to give me a 10x. And if I put the 4 here, there's a 4x. So our outside and inside terms, 10x plus 4x. There's our 14x. Okay, the first terms was our 5x squared, and the last term was plus 8. That's exactly what we want. Okay, it's kind of difficult, but there's a pattern to it. There's certain things that you're looking for to make it easier. So, like I mentioned in the first slide, there are some specific patterns. Okay, this one is called difference of two squares. Basically, you got a basic example would look like, well, the first example here, but x squared minus 4. Okay, x squared is a quantity squared, 4 is a number squared. This factors with this pattern, always. Now, it's got to be, it says difference of squares, so it's got to be this subtraction. So this would be x plus 2, x minus 2. Okay, when you see this pattern, this a squared minus b squared, it factors quickly following this pattern. So x squared, that's a perfect square. 121 is a perfect square. So this will factor to x plus 11, x minus 11. All right, for the second example, 4x squared, that's really just 2x quantity squared minus 8 squared. So it is a difference of squares pattern. So to factor it, that 2x is our a value, 8 is our b value. So we have 2x minus 8, 2x plus 8. Okay. Now, the last one, these are called perfect square trinomials. And so basically, you just have one binomial that you are squaring. And when you expand this thing out, it will always go to this pattern. So my x is the a value, so we're going to have x squared, 2 times a times b. All right, x is a, 2 is b. So 2 times x times 2 is a plus 4x plus b squared. Okay, x plus 2 quantity squared. If you were to FOIL that out, that's what you would be getting. So it follows that pattern. Okay, same thing when it's a minus b quantity squared. You're just going to have that minus there for that middle term. Which, looking at this first example, that's what we have, is that minus there for the middle term. So, we're trying to recognize the pattern, okay? This last term is a number squared. 16 is 4 squared. The middle term should be 2 times a times b. Well, if b is 4, 2 times 4 times x, there's our middle term, and this is just x squared. This thing is a perfect square trinomial because it follows that pattern. So, 4 was our b value, x was our a value, and because of that subtraction, x minus 4 quantity squared. Okay. For this next example here, the 3x squared problem, let me move this up a little bit. You should first notice there's a common factor of 3. Take that out. Always look for those greatest common factors. So if you factor 3 out, you're left with 3 times x squared plus 6x plus 9. Okay, that 3 is just going to stay out there the whole time. Now we're just concentrating on the x squared plus 6x plus 9. Again, this follows that perfect square trinomial pattern. That's 3 squared. This is 2 times 3 times x. This is the x squared part. Now, notice everything is positive. So, this is going to factor to x plus 3 quantity squared. Okay, that's the factoring for it. And we'll talk about this. I'll be in class on Thursday. We'll talk about this in class on Thursday. Sorry I wasn't here today. You guys are supposed to have a quiz. We'll do that tomorrow on Thursday. Hope everything goes well and hope you have a good day.